As you know in your everyday life, you don't walk at a constant speed. We calculate constant speed as the averages. But in here, moving objects don't travel at a constant speed. So let's take a look at Pete's 1,200 meter dash. We see that there's three things going on in this graph, three different slopes. The start of Pete's run is at time 0, down here. From 0 to 2 seconds, we know he's moving because the slope's going up, right? There's a gradual slope. From 2 seconds to 4 seconds, our graph levels out. We'll get to what that means in just a second. There is no slope between 2 and 4 seconds. But from 4 to 6 seconds, we see that it shoots up. So we have a greater steepness to the slope. So we can describe slope in terms like that, but we can get more mathematical about it and actually calculate the slopes. So let's look at Pete's start of his run. So what we need to start with is our rise. Okay, it's our distance traveled. So from here to here, where we see a change, we see that that's a single slope. That's one slope there. Once we see that the graph's changing, those are going to be different slopes. So at this change here, he changes at 200 meters, so that's our rise. 200 meters for this line. Our run is 2 seconds. We can see that. 0 seconds, 1 second, 2 seconds. So we put that, again, don't forget, our colors are coordinated. Our rise is in red, distance, and our run is in green, time. So 200 meters divided by 2 seconds gives us a speed of 100 meters per second. That's Pete's initial start to his run. Now let's look and see what happens to Pete during his run. We can see something change from 2 seconds to 4 seconds. So let's calculate that speed. We're looking at rise. If we're looking at the reds, does he go up any reds? He's at 200 at this point, at 2 seconds, and then when we get to 4 seconds, he's still at 200. So if he's at 200 meters here and 200 meters at 4 seconds, did he go anywhere? No. So he went 0 meters in a time of 2 seconds. 4 seconds minus 2 seconds. 0 meters divided by 2 seconds is going to give us 0 meters per second. Sometimes you might see these graphs and you think that there's just a flat line that they're going at a constant speed. But you need to look at the variables that are being tested for. The distance doesn't change, therefore Pete probably stopped to get a drink of water, maybe he had to eat a power bar, had to do something. But he didn't do anything between times 2 seconds and 4 seconds. He just stood there. But then at time 4 seconds, we see that he started moving again. How do we know he started moving? Because he starts going over distance. So we take a look at this one. Our rise from 200 meters to 1,200 meters, take the 1,200 meters, subtract the 200 meters, our rise is 1,000 meters. Our run time across here is 1 second, 2 seconds. So 1,000 meters divided by 2 seconds gives us 500 meters per second. Each slope can be calculated to tell us what was going on during a distance in time graph. So your turn to assess your understanding of what we just talked about. 2 questions you should ask yourself. First question, the blank of a distance versus time graph shows you the speed of a moving object. So you're going to fill in that blank. This is where you can pause, go back to the beginning of the video, whatever you need to do. Maybe you can do it off the top of your head. Second question, the rise of a line on a distance versus time graph is 900 meters. And the run is 3 minutes. What is the slope of the line? Again, hit pause, go back in the video, take a look at how you would do this. This is a calculation. And that's how you're going to assess your understanding.